Thank you. I'm very happy to be here. As Josephine said, I am based in Recorded Future's Boston office, so it's very exciting to be over here and see the vibrant community that you guys have here in Gothenburg. So, one big part of building any data model is figuring out how you're going to assess that model. In a lot of cases, this is done by measuring against some sort of absolute truth with measures like precision or recall or other sorts of things. In some situations, though, this isn't possible to do. For example, there may not be any gold standard for what you're looking at, or there just may not be data measuring it. In other situations, it may be possible to measure against some sort of standard like this, but that's not necessarily the most useful way to actually assess your model. So in this talk, I'm going to use our recorded future risk scores as an example of some strategies for how to build a quality model when testing against some absolute standard is impossible or undesirable, or even in cases where you do have that available to you, but you want to go the next step further. A point that I'm going to return to throughout this talk is the value of utility versus absolute truth. So everyone here has probably spent time thinking about how to produce a model that maximizes the performance on some sort of mathematical methodology. And this is definitely an important thing to do. But another key part of building any model is that it has to actually do what you need it to. And the information that you get out of it has to actually accomplish your goal. And this is the side of data modeling that I'm going to talk about today. All right, so first a little bit about our recorded future risk scores. At Recorded Future, we provide threat intelligence to security practitioners by ingesting a ton of data from across the web, processing it, and then delivering it to our users in organized, useful ways, all in real time. One of the ways that we present this data is through our risk scores, and I've shown an example here. For a specific indicator, say a domain in this case, or an IP address, we generate a score between 0 and 99 that presents some metric of how risky or malicious this indicator is. It's important to note here that when I say risk, I'm not talking about the precisely defined mathematical concept that many of you are probably familiar with. Rather, in this context, we use risk the way it's talked about in the threat intelligence community as a more categorical measure of the risk factors associated with something. And as such, part of the utility of our model is that we don't just present this number, but we also present the risk factors that contribute to it. So that's what this example is here of this box that's called out in this example. One of the challenges that we face is that there is no accepted gold standard for these risk scores. There are a lot of observations of different sorts of risk factors, different malicious behaviors across these indicators, but there's no one agreed upon metric for pulling this in. In addition, the users of our data vary greatly in how much they're willing to tolerate what they see as false positives versus false negatives, and how they actually process and use our data, and in their experience with threat intelligence in general. So even if we had one metric that we could compare against and get a solid model for, this wouldn't necessarily be the most useful thing for us to deliver. So then the question becomes, how do we take in these massive amounts of categorical and qualitative data and turn it into a number that actually does what we need it to? The first thing is to really make a point of focusing on the user and what they're trying to do with our data. In our case, the goal is that we present this risk score to an analyst, and they're able to quickly make a verdict or some sort of risk assessment on whether they need to act on this information or look into it more, or if they can safely ignore it. This may be done by a person actually manually examining the data, or through some automated process, or more often through some combination of the two. But regardless, the biggest feedback we get from our users is that they want to see the evidence and they want to see why we're assigning a score to something. So for that reason, we use a rule-based model where we have a bunch of different rules, and then those add up to the risk score, and then we can show those individual rules. That's not to say there isn't a place for more complicated machine learning. In fact, one of our risk factors shown here is a predictive risk model for IP addresses. And this is a really important part of our model, especially in situations where we otherwise wouldn't be able to say anything else about a particular indicator. But a lot of these models can be black boxes, and it's hard to peel back the covers and see why something has a high score in this model. And so that alone is not enough to provide utility to our users. So demonstrating these pieces together, what we present to our users is first the top-level verdict that allows them to make that first quick assessment. And then we describe the different risk factors with transparency, which again is key for our user base. And then in our product, we also provide some non-risk related information in the same place. So something that isn't necessarily part of our risk score model, but enhances the utility of the model if it's easy for people to find. One issue with any model is figuring out the balance between false positives and false negatives. This is especially difficult if you don't have a gold standard because there's no way to quickly get a measure of your false positive rate. It's even more difficult if the actual verdict is in some ways subjective. So in our case, if we're looking at a particular IP address, we may have some users who will consider it malicious if there is any malicious activity observed on that IP, even if it's also being used for more legitimate business. Whereas others really only think it's malicious if everything through that IP is malicious. And so this again makes it difficult for us to find that right balance. So we address this by making our model customizable in some sense in the output. With this rule-based model, we're able to compute different subscores that our users can then use. So here's an example of what some of our rules look like. Typically, we have a few dozen rules, and any indicator can match with 0 to however many of these rules. For each rule, we have some type of evidence that we present along with it. And then we also have a severity level associated with it. And I'll come back to these severity levels in a little bit more depth later in this talk. But the key part here is that for our novice users who maybe don't know as much about our product or as much about threat intel in general, they can focus on that severity level to help them figure out what they should pick out and how much they should be concerned about something. Our more advanced users may know that they really only care about a few of these rules and the others aren't relevant to them. And so they can pick out just the things that they care about and not the others. And this again goes back to figuring out a model that really provides that utility to our users and not just a number that is accurate. In addition, your metrics need to be useful. So even though we don't have a gold standard to measure against, it is possible sometimes to say that our model is not doing well. If we're constantly assigning high scores to things that our users don't actually care about, don't think are risky, or if we're consistently missing things that they do think are risky, our model isn't good enough, regardless of whether it is technically accurate or not. An example of this that we came across was looking at IP addresses that are used for sharing infrastructure. These are IPs that typically are associated with a lot of different domains, and these domains may, in some cases, be a mix between ones that have malicious activity going on and ones that are totally benign and may even be necessary for conducting regular business. And so this turned into a lot of perceived false positives where we were flagging in the IP as malicious. It really did have malicious activity. So in some sense, our model was accurate, but it wasn't useful for anyone because if they started blocking traffic to these IPs, they weren't able to do business. So I'm going to walk through our strategy of how we were able to go from this kind of qualitative, subjective metric to something that we could actually implement. We started with a top-down, human-based approach of actually looking at the data manually. So here, I've made up the actual samples here, but the concept is what we actually did. So we started by pulling some IP addresses that we thought may have this problem, and we went through and manually annotated them. So some of them we were able to see were clearly hosting providers. Some of them were cloud services, and then there were some that looked like they really had an appropriate risk score, and we didn't need to change anything. This process obviously doesn't scale very well because you need to have a human looking at it for each line. And I think for some of us who are more programmatically minded, it's tempting to try to figure out a way to automate the human out of the loop. And definitely there are situations where that's what you want to do. But I would encourage you to, if you're going down that route, think about whether that's really the thing to do. Because sometimes having a human judgment is what you need here. And in this case, we really needed to have people looking at it to be able to formulate some sort of general idea of what to do. So once we'd done that, we moved on to a more bottom-up automated approach. Looking back at these same IP addresses, we were able to get a number of associated hosts for each of them, and then develop an algorithm where if the number of hosts was high, we would treat this as some hosting provider or cloud services and decrease the score appropriately, whereas the ones with the low number of hosts we left alone. This obviously scales much better. It's a very simple algorithm that we can have a computer run. But importantly, we wouldn't have been able to get here if we hadn't had a person actually looking at the data to start out with. So putting these together, we developed this method where for a given IP address, we would test it against this method. If it applied, we would reduce the score down. And then very importantly, we put that evidence right in our output so that it's transparent to our users. And if someone's looking at this and wonders why it doesn't have as high a score as they would expect, they can see exactly why and make use of that. So a piece that I've already touched on a little bit is getting expert opinion on your model. Pretty much any model, at some point in time, you should talk to someone who's an expert in the subject. In some cases, you may be that expert. In other cases, you'll need to reach out to someone. I'm definitely not a cybersecurity expert, so I lean very heavily on the other people at Recorded Future who know way more about this subject than I do. Regardless of whether you're using your own opinion or getting someone else's input, you can do a lot to organize your data in a way that really facilitates this process and make sure that it's actually valuable and not just a pointless exercise in getting different opinions. Part of this is getting different categorical judgments to make your feedback more useful. Often a yes or no verdict is more useful than a more free-form comments, or even if that more free feedback is useful, it's good to also have the verdict so that you can easily interpret it. It's also important to make sure that whatever feedback you're asking for is clearly defined. Just asking someone, does this look right or not, is a bit vague, and you can go much further if you have a very firm, like, would you take X action based on this? As an example here, we ran into some issues where really popular high traffic domains, think of things like yahoo.com, were getting risk scores that were higher than were practical for anyone to work with, whether or not that was based on reality. So then we, of course, pulled some sample data to look into possible solutions. So here's an example of the type of spreadsheet we looked at. I've replaced the actual domains we were considering with some dummy data, but otherwise this is a straight copy-paste from the Google Sheet that I made for this. Important parts here, we have some of our key numbers in the middle. These are the metrics that we know we're going to need to be able to make this assessment. We also, over on the right, have a number of different ways to filter down to interesting data. In this situation, we used our different risk rules as filters. And then importantly, we also have a column where you can pivot out to get more information. This last piece, I think, is something that is easy to overlook because it's not necessarily part of your model, but it will go a long ways towards making your expert opinion more efficient if you make it easy for them to get more information if your table doesn't have everything that you need. So then we were able to find this one particular filter, the threat researcher rule, where over 95% of the samples that we looked at in this set were very clear false positives. And even the other 5%, probably some of them were false positives, they were just a little bit trickier to determine. So this gave us a very easy way to make a rule that we were able to use to knock out some of our false positives and then easily reduce these false positives here. So this, obviously, I've just shown you an example of when this worked well. As you all know, sometimes things don't work so well. So this is from that same project. We had this particular ranking mechanism that we had in place. And our initial intuition was that we'd be able to just choose a cutoff, and things above that were going to be mostly false positives, things below would be mostly true positives. That turned out to not be the case. We found counterexamples both at the top and the bottom of the list. There may have been something sophisticated we could do there, but we very quickly determined from looking at this that it wasn't the most efficient way to go down our path. But the good thing was that we had our data organized like this, so it was very quick once we actually found the data to realize that this was the wrong way to go and pivot over to the much more effective method that I showed you. Finally, for your model to be useful, it needs to be interpretable. As people, we're generally pretty bad at making sense of raw probabilities. So if, for example, you tell me something has an 80% likelihood versus a 60% likelihood, chances are I'm not going to appropriately discriminate between these two. If your model is going straight into another algorithm, that's totally fine to have the precise numbers. But at the end of the day, if the output of your model is going to be looked at all by a person, it's better to be able to get it down to a small number of different categories. For the maximum utility, you should make these categories things that are actionable so that people know what they mean. And if needed, you can add some more details within the category. The way we do this with our risk scores is by having a few different severity bands. And we color code them from gray to yellow to red so that it's really easy to see at least generally which one you're in. And then for each of them, we have a description going at the very top, like our very malicious level. These would be indicators where if you see one of them, you definitely want to at least investigate it more, if not take actual action. The opposite end, our unusual category, has things that we consider more informational. If you run into one of these, we're not saying that you necessarily need to be worried, but if you're investigating an incident and you're looking into one of these, it may be important to have this additional information to get a broader picture. And so these different bands are how we make sure that our model is really useful. So now that I've shown you this, you may wonder why we have that 0 to 99 range in detail that I mentioned before. Part of that is that we know that people naturally are going to want to see more detail and have more breakdown, and so we want to provide that. But the other part is that we're able to present additional information with this further breakdown. So the way our model works, for a given indicator, we look at the different rules that match it, and the maximum severity level of those rules becomes the severity level for the indicator. But then within that risk band, say suspicious or malicious, the more evidence we have, the higher the score in that band. So ranging from 25 to 65, we have a higher degree of confidence that whatever we're looking at actually is suspicious. Importantly, though, there's a big difference between increasing the score within a band and increasing the score between the bands. So jumping between suspicious and malicious is not the same as just saying something is more suspicious. No matter how suspicious something is or how sure we are, it's not necessarily malicious. And this enables us to keep the simple output of these small number of different categories, but also provide more detail in the exact number. When figuring out your categories, it's, of course, useful to look at your data. When possible, it's best to keep your top most actionable level on the small side. For example, for us, less than 0.01% of our IPs with risk scores are in our very top level. Part of that is to avoid fatiguing your users. So even if you have a top category and based on your definition, a lot of things fall into that category, if your users are getting alerted on it constantly, they're not going to be able to process all of that information. And so you want to make sure it's something that they're not going to just get overwhelmed by. Also, having a small top level makes it easy to find the things that matter most and have a range of things that, again, you can actually work on. On the other side, anything where you know there's a high false positive rate, you probably want to keep it down at a low severity, less actionable level. For us, this would be things like where we see an association between an IP and some sort of malicious activity, but aren't able to say that the IP is directly involved in that activity. So this is something that it's important for us to surface this information. It could be very critical for people looking at it, but we know that there can be a lot of noise, and so we want to make sure that we keep that down at a low level, even though it's still in our model. And finally, as with everything I've said, get feedback from practitioners. Make sure that the people using your model are going to be able to actually make sense of your different levels. Putting this together for our risk scores, we have first our top level. This very malicious rule triggered in this case, so that brings that score up to 90, and we've color-coded it red so that you can't miss that fact. We then have this extra evidence that provides the detail, bumping it up to 93. And then we've provided over here all of the detailed evidence to make it transparent to our users and have a model that really is useful for what we want them to be able to do with it. So to summarize, I've talked about a few different ways to make sure that your model is not just technically sound, but actually useful. The first and foremost thing is to focus on your user, and what they're going to actually do with your model. Second, anytime you have a human in the loop, and definitely there should be some times when you have a human looking at this, you want to make sure you're smart about how you get their input. And then finally, make sure that whatever numbers you provide as the output of your model are things that can be interpreted and acted on. So I want to end by thanking the organizers for inviting me, and thank you all for listening.